Hi, the question I want to ask in today's video is what would it take for me to trust AI generated code, or at least code that was created using AI augmented software development techniques? That's a simple question, so let's just make sure we're hydrated, put on the old background music, we're going to get into it. I want to start with an anecdote, and it's one that's written by Bertrand Bayer in his book Agile, the Good, the Hype and the Ugly. It's a short story that's the postscript to chapter 2 on understanding the rhetorical arguments used in promoting agile software techniques. So this next section is an extract that was written by Bertrand Bayer. On a cold morning of February 2012, Mr. S woke up early. He had set up his iPhone's alarm to a favourite tune from Götterdämmerung, downloaded from a free MP3 site. He liked his breakfast eggs cooked in a specific way, and got them exactly right, since he had programmed his microwave oven to the exact combination of heat and cooking time. He had left his car to his daughter on the previous night, even though the roads were icy. He did not worry too much for her, since the automatic braking system was good at silently correcting the mistakes of a still somewhat novice driver, and a navigation system would advise her away from any impracticable street. As for himself, he was going for public transportation. He looked up the schedule on the web and saw that he had a few minutes before the next bus, enough to check his email. He noticed that he had received as a PDF attachment the payslip for his last consulting gig. As an agile consultant, Mr. S was in high demand. He did not need to check the details, since he knew his accountant system would automatically receive all of the information. He went out and hopped onto the bus, all the way to the client's office, continuing to check his email on his phone, even finding the time to confirm the online reservation for his next flight, while checking the large monitor in the bus to avoid missing his stop. On reaching the building, he slid his ID into the elevator's slot, gaining access to the right floor. He brought up his computer from hibernation, for some reason remembering, Mr. S was fond of such trivia, that the newest version of Windows reportedly consisted of over 50 million lines of code, and reflecting that the system now kind of did what he expected. Mr. S had thought of moving to a Mac following many of his friends, but the advantages were not clear, and he liked the old Word text processing system with which he was writing his latest agile advocacy text, tentatively entitled Software in 30 Days. Mr. S, whose full name was either Schwaber or Sutherland, although it might have been Scrum or perhaps Sprint, as some of the details of the story are missing, opened up the document at the spot where he had left it the evening before. Like many a good author, he had postponed finalising the introduction to the last moment. Until now, inspiration had failed him and his co-author. It is always so hard to discover how best to begin. Over the past months, working together in long Skype discussions from wherever each happened to be, they had tried many different variants, often simultaneously editing their shared Google Docs draft. But now he suddenly knew exactly what he had to say to capture the reader's attention. The sentence sprang to his mind in one single felicitous shot. You have been ill-served by the software industry for 40 years, not purposefully, but inextricably. Okay, so that's quite a fun anecdote, and the point that Bertrand Bayer was making in his book on Agile was that Agile software consultants say that the software industry is in a really bad state and you can't trust any code because you've been badly served by the industry, when in fact they use a lot of software that they trust every day to do that. In the context of this discussion, bringing up all of that software that we use and trust to do our work or whatever it is that we're doing every day, makes us ask, what is it that's special about AI generated code? We already use loads of software without actually inspecting it, even kind of considering the open source or free software that's part of the software I use every day. I've read a very small fraction of it, and like worked with even less of it. And a lot of the software is proprietary. You're either watching this video on YouTube or Patreon. We use and trust those platforms all the time. And the code was not generated by ourselves. It was generated by some other agent. Most of it probably by human agents. But there's no, what is there about AI generated code or AI augmented software techniques that makes them categorically different? Why should we have a different level of trust for code that was generated by someone typing their ideas into the Emacs text editor than someone who typed their ideas as prompts into the Emacs text editor and then used GPT-EL to generate the software? This also applies when working as a software development. It doesn't take too many people on a team before, on the one hand, there is too much code, and particularly if the project has been running for a long time, even if you can keep up with the changes on the code, you can't necessarily also understand the history and evolution of all of the software that came before that. So no one individual in a software company actually inspects all of the code. Maybe it is all inspected. Every change has to be reviewed by at least one other person before it goes in, whether it's an AI augmented change or not. But we're still relying on and even distributing to our customers code that we personally haven't read. So I come back to my question: is there a categorical difference between code that we haven't read, that we distribute to our customer, that was typed in by another human, and code that we haven't read and we distribute to our customer that was typed in or generated by an AI augmented assistant? So then what about software that I make myself? What do I need to do to be confident about the software that I create? Even that could be the wrong question, but let's have an investigation on it. So I already use validation techniques that demonstrate whether the code that I create, whether I'm using AI augmented tools or not, that the code I create does what I think it should do. I use test-driven development. You'll see the book Test-Driven iOS Development round here behind me somewhere. Not very good at using a flipped mirror to point at things. I also use design by contract, and it's possible to get agents to well, it is possible to get agents to do both of those. Test-driven development, you certainly can, and there's an example in the extract prompt pattern description of following the Canon TDD workflow by creating separate prompts for each of the stages and ensuring that the agent follows them in order. Design by contract have had a lot of good results using the object constraint language to encode preconditions, postconditions, guards, invariants about software design, and then getting an AI augmented coding assistant to generate code that not only constrains itself within the rules laid out in the OCL design, but that also encapsulates those constraints in assertions and checks in the implementation. So we could continue to do that with our AI augmented tools. Of course, if I write the code, the tests, and I write the contracts, I'm losing some of the automation benefit of using the AI augmented coding assistant, because it's only filling in the implementation details for something that I've had to effectively code manually in the form of the automated tests. And if we say, okay, well, let's let the AI tool, the language model, generate both the codes and the tests, and I, as a human reviewer, only have to review the tests and then run them and ensure that they pass and that the implementation code does have the behavior that's encapsulated in the tests. That's the trust the tests design pattern that is coming up in the Chiron Codex pattern language. We've still only kind of moved the problem out, and any approach that where we say, okay, we'll build this model of the software's behavior, we'll review the model, or even we'll get the LLM to generate a model of the software's behavior, and then we'll review that model. It only moves the problem to one level of abstraction. We now have to, we're still reviewing by inspection everything that the model is doing. We're just doing it at one remove from the working code and trusting that that model accurately captures all of the behavior of the code that the agent generated. And that goes for any model-based approach. Many people are enthusiastic about the ability to adopt formal methods, like proof models like TLA plus or COC, or Z, for example. There's plenty of books on Z up here somewhere, which, again, these are models of the software's behavior, and we have to, if we review the model and decide it's correct, we have to keep up with changes in the model as fast as our assistant is generating them, and B, we then apply some level of hope that the actual behavior of the software reflects what's encapsulated in the model. We've got the same kind of trust problem. We just moved it out slightly. Instead of saying, I don't trust this code, I'm going to inspect it all, we say, I don't trust this model, I'm going to inspect it, but I now do trust the code because my assumption is that the code implements the behavior that's expressed in the model. So can we get to a point where we don't have to inspect everything, where we're not reading the output, we're relying on the assistant or agent doing the right thing and generating code that satisfies our requirements? Well, we can certainly reduce the amount of reading we have to do, and if we use, say, property-based tests, we can make general assertions, or rather the property-based tests make general assertions about the software's behavior, which cover more situations than a traditional S-unit style test, which covers a single scenario. Given these input conditions, when the code does this, we expect this to be the output. A property-based test says more like, for any input of this structure, when we do this thing, these are the conditions we expect to hold for the outcome. We'd still want to understand those property-based tests, but we would have a smaller number of tests to cover the same amount of behavior. Other options we have include static analysis tools, because they can tell us something about the behavior of software just based on an inspection of the software artifact itself, without having to actually kind of read the software, without having to kind of simulate a computer in our heads, without having to inspect the actual statements that were generated. And they will typically catch common anti-patterns. It's rare to find, or very unlikely to find, a static analysis tool that tells you something positive, that whether a particular customer requirement is met by analysing the software that's created. But we can at least say that whole classes of bugs don't exist, and use the output of the tool as a feedback for the agent. And instead of having to inspect the results of a static analysis tool, if it reports any issues, feed those back into the agent. A related tool that addresses a big deficiency in the LLM augmented coding assistant is a symbolic execution tool. These inspect the code, and they they effectively do the reverse of design by contract. They reverse engineer a contract through the implementation. So they understand what statements, what predicates are true about the software at every step in its execution, and investigate how the software evolves, and if it terminates at a particular point, if it accesses memory that isn't allocated, if it does some other behavior that would definitely indicate problems, then it can report that, and they make up for the deficiency that an AI augmented model, one that's based on a large language model or LLM, doesn't have a symbolic understanding of software. It doesn't reason about the behavior of the code, about the dynamic evolution of the software or its state. They are generating language tokens, and those language tokens happen to be in a programming language when we use them to generate code. So that's why you see, if you ask a coding assistant for help with debugging software, one of the first things it will reach for is print statements, adding logging to all of the code that's associated with the problem report. The language model can't understand what the code does, but it can interpret a sequence of text, and so putting print statements in turns the dynamic behavior of the software into a sequence of text. If a human did that, we'd call it cave dweller debugging, because we have much better tools for understanding, inspecting, and modifying runtime behavior. But those tools, even if we make them accessible via MCP or skills or some other approach to an LLM, don't fit the tokenized text sequence generation approach that models use. So now we've got a tool that sits outside the, for want of a better word, conceptual model that the LLM is using, outside the generating a sequence of program text that looks like it addresses the prompt, and sits in the model of understanding the dynamic behavior of the software. We've got two different models of the software now, and we can combine them to automate the validation of the software. And then there's mutation testing. Mutation tests aren't a form. There isn't mutation tests. They aren't a form of test like a unit test or an integration test. Mutation testing is where you take your existing test suite and your existing system under test. You make a change to the system under test. Maybe you reverse the sign of a comparison. So if there's a less than comparison in the code, you change it to a greater than or equal. And you run the tests, and you ensure that for any mutation you make, one or more tests fail. And the reason for doing that is that demonstrates whether your tests are actually going to catch regressions. If you can change the behavior of the code and not get a different outcome from your test suite, then your test suite isn't actually verifying whether that behavior that you modified is present or not. So if we had mutation tests that told us that the LLM generated tests could catch any regression in the LLM generated code, we wouldn't need to read the tests to understand that the code was being well tested. But would that tell us anything? Would that tell us that the customer actually wants the behavior that is demonstrated in the code? Well, that's not really up to me. Like, I'm the software engineer. I'm not the customer. I can't decide whether the customer is happy, whether the requirements, whether the software meets their requirements. They're customer acceptance tests, and as such, the customer gets to choose what to do, how much trust they put in, how much testing they want to do, whether they see the behavior as acceptable or not, whether they need something to change before they use the software, or whether they can use the software now but would require a change to be made later. So really the answer is what the answer has always been. It's not up to me to choose whether to trust the AI generated code or not. It's not up to me to trust the code whether or not it's AI generated. It's up to me to negotiate with my customers and make sure that they're confident with what we do, and to provide any information they need to generate that confidence, whether it's automated tests, whether it's static analysis output, whether it's mutation testing or symbolic execution results, formal models. It's up to them to be happy with what I'm doing, and as the Agile Manifesto said 25 years ago, the customer collaboration is one of the most valuable parts of software engineering. Particular choices of tools, whether it's favorite text editor, UML modeling tool, AI-augmented coding assistant, doesn't change any of that. But the way that we use these tools can help. There's a pattern in the Chiron Codex pattern language for AI-augmented software development called Disclose Ambiguity. It's currently available to paid patrons over at the Chiron Codex Patreon, so please do go and check that out. And it's really helpful for understanding whether we've met customers' expectations, because it tells us whether there are unstated assumptions, ambiguous statements in our requirements that when we let a model implement the code, it will effectively bake in a choice on those ambiguities or assumptions that might not be the choice that our customer wants and might not be the choice that we would have made. So do go and check that pattern out at the Patreon. Consider becoming a member. It supports generating more content like this. It supports further investigation into how we become software engineering centaurs. Also, like this video, subscribe to the channel. Thank you very much for watching, and I'll see you again.